Hi guys, it's Miss Rooker again. I'm going over the final review, starting with number 26. All right, a particular jeweler uses that formula to relate the average diameter of a cultured pearl in millimeters to its weight in carats. The jeweler sells the pearls to a customer for $4.25 per carat. If you pay $25 for a pearl, what should you expect the diameter of the pearl to be? All right, so we are paying $22, and we know that it is $4.25 per carat. So the first thing we're going to do is find out how many carats it is. So to do that, we're going to do $22 divided by $4.25 per carat. So 22 divided by 4.25 is going to be 5.1765, somewhere in there. Then, so that's now the weight of the carat. Now I'm just going to plug that into my equation. What I'm going to do is plug that in for the W in the equation. So it's going to be 4 times the 5.1765 divided by that decimal and then cube rooted. So let's do that in the calculator. So cube root is not on the home screen, so we have to go to math, down to cube root. And then I'm going to put a fraction in there. And then it's supposed to be 4 times 5.1765 all over 0.02847. 0.02847. And I get 8.99, which is about 9 millimeters. All right. Moving on, number 27. Find 2 times f of x minus g of x and f of x plus 2 times g of x for those two functions. So it just means that we're performing these operations, two different things, two different problems, I guess. So the first one, we're going to do 2 times f of x and then subtract g of x from it. So I guess I'll do that off to the side. So we'll do 2 times f of x. So we'll multiply this by 2. So it'll be 2x squared minus 2x plus 12. And then we're supposed to subtract g of x from that. So g of x is negative 2x squared plus 2x minus 7. Since we're subtracting, we need to distribute the negative. So this will end up being positive 2x squared minus 2x plus 7 when we distribute the negative. Now combine like terms. 2x squared plus 2x squared is 4x squared. Negative 2x minus 2x is negative 4x. And then 12 plus 7 is 19. So that looks like it should be either C or D. And now we're going to do the other part of the problem. So this one is just f of x plus 2 times g of x. So f of x is x squared minus 7x, just minus x plus 6. And then we're going to do 2 times g of x and add that to it. So 2 times g of x, I'll just put this here. 2 times g of x is negative 2x squared plus 2x minus 7 multiply in the 2, so this will now be minus 4x squared plus 4x minus 14. Combine like terms, x squared minus 4x squared is negative 3x squared. Negative x plus 4x is positive 3x. And then 6 minus 14 is negative 8. So that means our correct answer should be C. Number 28 says let f of x equal that function and g of x equal the other function, and then find f of g. This notation does not mean multiply f times g. It means f of g of x. What this means is you're plugging g into f. This notation means the exact same thing as what I just wrote. So that's what we're doing, is we're plugging g into f. So the way I like to do this is I write f, which is 5, but I don't put x. I instead put a parentheses, and that's where I'm going to plug in the g function. So this gets plugged into those parentheses. So this would be 125 over x to the 1/2. All right, and now we need to simplify. So trying to think, the easiest thing might be to rewrite this in radical form. So this will be 5. I just mean the outside in radical form. So this will be cube root, because the 3 is on the bottom. So cube root, and then the squared will be on the outside, 125, and then it'll be x to the 1/2. I'm going to do this kind of in 2 separate steps, actually. So I leave the 5 on the outside. That doesn't have anything attached to it. It's just 5's in front. There were no parentheses telling us that the 5 goes in the radical. So the 5's just in front. And then I'm going to rewrite this as cube root of 125 squared over cube root of x to the 1/2 squared. The reason I'm writing them as 2 separate radicals is because this one is a perfect cube. So I want to cube root that. So cube root of 125 is 5. We still have the squared. And the bottom one's not a perfect cube, but these can cancel each other out. Power to power, we multiply, so 1/2 times 2 just becomes 1. So those just cancel out. So we just have cube root of x on bottom. So then I would just simplify these. So this is 5, and then this is 25. So 5 times 25 is going to be 125 cube root of x on bottom. So we'll have 125 over cube root of x. The reason this isn't an acceptable answer is because we're not allowed to have a root on the bottom. To cancel out a cube root, we need groups of 3. We only have 1 x, so we need 2 more. Whatever you do on bottom, you have to do to the top. So x times x is just x squared. So the top will be 125 cube root of x squared, and the bottom, an x will break out of the radical. So that should be our answer, which is answer option B. That was a tricky one. All right, next one. Given the graph of f of x below, what is the value of f inverse of 4? So what this means is, this notation here, f negative 1 of 4 means f inverse. So we're taking the inverse of f of x. So what I would do first is just graph the inverse of this function. So the inverse means you switch all the x's and y's. So like this one contains the point 1, 0. Ours should contain the point 0, 1. And then this one contains the point 0, -1. Ours should contain the point -1, 0. And then, did I mess that up? Let me go back. It's hard to highlight and do these at the same time. All right, so this has the point 1, 0. Ours should be 0, 1. And then this has the point, let's see, 2, 1. Ours should be 1, 2. And then this has the point, let's see, 4, 3. Ours should be 3, 4. So what ends up happening is the inverse ends up being here. Let's see. Let me just get a couple more nice points. So this is the coordinate point. This one right here is -1, -2. Ours should be -2, -1. So it's there. And then this is -3, -4. Ours should be -4, -3. Okay. So the line ends up looking like this. So the blue line is the inverse. And then it's just asking what is the value of f of 4. So what that means is we plug 4 in for our x value. So if we plug 4 in for our x value, what's our y going to be? So all I have to do is go to 4 and see what the y value is going to be on our new graph. So if I go over to 4, it's up at 1, 2, 3, 4, 5. Another way you could do this is inverses just mean the x and y are flip-flopped. So if you're trying to find the inverse of f of 4, then you would just find where the y coordinate on the original graph is 4. So that's over here at 5. All right, determine whether those two functions are inverses. Explain. All right, so the rule is if you plug one of them into the other one, so you do a composition of them, and it simplifies to just x, then they are inverses. So if you look at answer option B or D, that's what we're looking at, is we're going to plug. It doesn't matter which one you plug in, but according to this, they're plugging G into F. And if it simplifies to X, then they will be inverses. So that's just what we're going to do. We're going to take F, but we're not writing X. Instead, we're going to plug G into it. And then we'll simplify this and see if it simplifies to X. 2 times a half cancels, so this will just be X. 2 times 2 is 4. The 4's will cancel, so this simplified to X. So since it's simplified to X, they are inverse functions. All right, and find the inverse. To actually find the inverse, you switch X and Y and solve for Y. So this will now be X, this will now be Y, and we solve for Y. To get rid of the fifth root, we need to raise everything to the fifth power. So this will now become X to the fifth power equals 2y plus 8. Then subtract 8, so we get X to the fifth minus 8 equals 2y, and then finally we'll divide everything by 2. When we divide by 2, I notice my answer options, they divided each term separately by 2. So we get X to the fifth over 2 minus -8 divided by 2 is going to be 4. So that should be our answer. Also, they wrote it as 1/2 X, not X over 2. So let's see, that looks like answer option B. All right, which equation is represented by the graph below? First thing is So I noticed that this is an exponential function. It's technically an exponential growth function because it's getting further and further away from the asymptote, but it's a negative growth, meaning because it's below the asymptote, it's going to have a negative a value. So it can't be d because d has a positive a value. Also, there's a typo on C. It's not supposed to have two equal signs, so just ignore that. All right, the next thing that I'm going to look at is the asymptote placement. The asymptote's up at 2, which is correct for all 3 of those. So all 3 of those are good for the asymptote placement. Let's think. Next thing I'll probably look at, honestly, what I would probably do from here is just plug in a nice point and see which one it works for. So for example, I notice that this graph contains the point 1, 0. So whichever one of those functions contains the point 1, 0 is going to be the correct one. Unless it's a coincidence that it contains 1, 0, so you want to check all of them. Because if more than one contains 1, 0, then you'll want to try another point and see which graph contains both of the correct points. All right, so I'm going to start with the top one. If we plug 1 in, 3 to the first power is 3, times negative 2 is negative 6, plus 2 is going to be negative 4, not 0 like I wanted. Then plug into the next one. 1 minus 3, so I'm plugging 1 in here. 1 minus 3 is negative 2. Negative 2, 2 to the negative 2 power is going to be a little ugly. So 2 to the negative 2 is going to be, let me just write this out. So 2 to the negative 2, this will be 1 over 2 squared, which is going to be 1/4. This negative just stays in front. Negative 1/4 plus 2 is not going to be 0 like I want it to be. So now I plug into the last one. 2 to the first power is 2, but then this negative still in front, so this will be negative 2 plus 2, which is 0. So C gives us the correct answer. If you would rather, you can just type each of those into the graphing calculator and see which one gives you the correct answer. All right, which of the following statements are true? Select all that apply. So what I would probably do if I were you is type this into the graphing calculator first. I'm going to graph by hand really quick, but you could use your graphing calculator. The asymptote is going to be down at negative 3 because that's your K value. First thing I'm going to do is find my critical points. I find them by plugging in 0 and 1. So I ignore these values, plug in 0 and 1, and then I'll shift them. So plugging in 0, anything to the 0 power is 1. Oops. Anything to the 0 power is 1. Anything to the first power is 1/2. All right. So the way this is going to look is I would take those 2 points, so 0, 1, and 1, 1/2, and then I would take both of those and I would shift them left 1, down 3. So left 1, down 1, 2, 3. Left 1, down 1, 2, 3. And then just draw kind of a rough sketch. Again, to save yourself time, you could do all of that in the graphing calculator if you'd rather. All right, the domain is how far left and right it goes. There are no boundaries to how far left or right an exponential decay graph goes. So that would be all real numbers, not that. All right, the range is negative 3 to positive infinity. The lower boundary is down here at negative 3, and it goes up to positive infinity. So that is correct. The x-intercept is negative 2. in looking at my graph, it's actually hard to tell if the x-intercept is -2. So what I would do with this is type it into the graphing calculator, or you could plug in -2. Let's go ahead and plug in -2. So if we plug in -2 in for x, this would be -2 plus 1, which is -1. The -1 exponent flips this whole fraction, so this will be 2 minus 3. 2 minus 3 is 1. So that means that it contains the point -2, 1, not -2, 0. So it's not H. Again, that would have been a really quick check. You would just graph the original in the graphing calculator and go to the table and see if it has an x-intercept of -2, 0. All right, the asymptote is down at y equals -3. That is correct. And then it says as x approaches positive infinity, which means as we go to the right. So as we go to the right, is the function approaching -3? Yes, it is. It is approaching. Your function is approaching the asymptote, which is at -3. So your correct answers should be G, I, and J. Two types of cars have been have different projected depreciation values. Their changing values are modeled as shown. Find the average rate of change of the value of each car over a 10-year period. Which of the following statements is correct? All right, so to find the average rate of change, we want to see how much it went down, and then we just divide that by how many years it's been. So like on example 2, we really just need to take those 2 points and then to find the difference, how much it went down, and then divide that by 10 years. So it looked like they were at, on the side here, it says the value in thousands. So the car started at about, let's call that 32,000. And then it went down to, gosh, what do we think, 6,000? Yeah, we'll call that 6,000. So it went down a lot. So 32,000 minus 6,000 is going to be, it went down 26,000. Went down to 26,000 in 10 years. So to find how much it went down each year, we just divide that value by 10. So 26,000 divided by 10 is going to be 2,600. So it went down by about 2,600 per year. So looking at the answer options, we can cross off D because it says the value decreased by an average of 9,000 something. It did not decrease quite that much. And then what I would do for car number 1 is I would plug in 2 values for this one. So the first value I'm going to plug in is 0 because we want to know how much the car was worth in year 0, meaning the first year that it was, that it was out. So plugging in 0 tells us basically the starting value. Anything to the 0 power is 1. So 1 times 30 is going to be 30. So this started out at 30,000. That's how much it cost in year 0. Then the next number I'm going to plug in is 10 because I want to see how much the car was worth in year 10. So I'm going to do 0.87 to the power of 10 and then multiply that by 30. And that gives me that after 10 years, the car is now worth 7,453-ish. So that's about how much it is after 10 years. Remember, these are in thousands. So the answer I got was 7.452 or 7.453. But we need to multiply that by 1,000 because we want the value in thousands. All right, subtract those to find out how much it actually went down. So 30,000 minus 7,453. And I got that the car depreciated by $22,547 in 10 years. So I divide that by 10. So it went down by about 2254.7 per year. That's how much car one decreased by. So which one decreased more rapidly? Car one. So actually, sorry, I was confusing myself for a second. Answer option A says car one decreases more rapidly. Well, this is how fast car one depreciated. This is how fast car two depreciated. So car two actually depreciated by more each year. So more fast, more rapidly. Car one decreased by an average of about 2255. This is just about 2255, and not 13,000. So the answer is B. Three people in business club are competing to see who can double their investment in the shortest amount of time. Each person starts with an initial amount of 5,000, but they each choose different investment scenarios. Who will double their investment first based on the following information? All right. What is important for you guys to be aware of, what I talk about a lot, is that rate is usually, rate has more of an impact on your the amount that your money is going to grow than the compound frequency. So the first thing I look at, since they're all investing the same amount of money, $5,000, first thing I look at is the rate. I am assuming, or I'm guessing, that the correct answer is going to be that person C will double their money first. So I'm pretty confident enough that I'm even going to circle the answer, but it's always smart to check just to be sure. Interest rate will have a big impact, where the compound frequency is usually just a matter of a few dollars or cents difference between quarterly versus daily versus continuously. So what we're going to do is plug all the values in and see which one reaches 5,000 first. So doubles first. Is that what it says? Doubles, yeah. So we're going to start with the first one. This will be 5,000. And then the rate is 0.059 because you move the decimal over 2. If we're compounding quarterly, that means 4 times per year. So your N value is going to be 4. And we don't know the T value yet. So we're going to plug this into our calculator. I'm going to go to my table of points. Oops. So I go to y equals, and then I'll go to my table once I type it in. So go to y equals, I forgot what I was typing in. 5,000 times 1 plus, and then we'll do a fraction. And then this should be, 0.059 over n, which is 4. Let me close the parentheses there. And then this should be to the power of 4t. We don't have a t on the calculator, so we just use our x. And then we'd go to the table of points. Whoops. Oh no, it cleared it all out. Okay, guess I'll type that back in. 5,000 times 1 plus fraction 0.059 over our n value, which is 4, since it's 4 times per year, close parenthesis, to the power of 4x. Now we go to our table of points. And at year 0, we should have $5,000. And then our money should be going up. We want to see how long it takes to double our money. So double the money would be 10,000. So we're just scrolling until we hit 10,000. It takes about 12 years. So between 11 and 12 years. Okay, now all we're going to do is change. The only thing we're changing is that it's compounded daily, not quarterly. So we're just going to change this n to a 365 in both places. Oops. So in our calculator, we're going to go back to y equals. We're just going to change this. We're going to insert 365. So this 4 is now going to be, let me delete that, 365. Go back to the table. And this one, again, will double between 11 and 12 years. So I'm not surprised that these are pretty close because they have the same interest rate. If we wanted to know which one of those was first, well, logically, this one, daily, should have a slight advantage over quarterly because it's compounded more frequently, but not that much. Now, the next one I'm going to do is I'm going to completely change the equation. This is now going to be 5,000 times E. 5,000 times E to the, it was supposed to be 6%, so 0.06 T, or X. I believe that's what it was, right? Yeah, 6%. So this is going to be 5,000, and the rate is 0.06, and again, we don't know the T. So we're going to put this into our table of points. And we can see, we can see that again, it reached 10,000 between 11 and 12. But, so that was a little bit of a waste of my time. What I should have done is zoomed in my table. So I should make this count by decimals. So I do plus 0.1, and now it'll count by a decimal, so I can get a closer picture of exactly where it's hitting. So this is hitting 10,000 between 11.5 and 11.6. And then we would want to go and compare that to these ones. But the fact that this has the best rate and compounded continuously is going to be a slight advantage over compounded daily. There's really no way that C can't be the best option. All right, a cup of soup is placed on a kitchen table. The temperature, Y in degrees Fahrenheit, of soup can be modeled by that function, where X represents time in minutes. Which of the following statements correctly describes the graph of the function? Well, might as well graph it on the graphing calculator. That's going to be our quickest, easiest bet. So we'll do 70 plus 122E. E to the negative 0.07x. All right, and then we'll go into the table of points. My table is still counting by decimals, so I'm going to go on a whole number and then change that to +1, so it's counting by whole numbers. And then we'll just go in the table. Well, let's go back and see what they're asking us for. It's saying the x-intercept is 70, 0, and the y-intercept is 0, 122. Well, I can see that the y-intercept is not going to be 122 because I see here that the y-intercept is 129, 0, 129. So it can't be 122. The x-intercept is 70, 0. So let's go see. We could scroll all the way to 70, or what I could do is scroll to a nice number and say I want to go by tens instead so that we can get to 70. And then here it says it's 70, 7.9. That's not the x-intercept that we wanted it to be. The temperature of soup is initially 68 degrees. 68 degrees. Well, the initial temperature is going to be the temperature that you get when you plug in 0. Or that should also be your y-intercept because it would be the point 0, something. And we saw that the y-intercept was actually, let's keep going. The y-intercept is 129, meaning the initial temperature is 129, not 68. So it's hot soup. It starts off hot, and then it'll cool down. And then the minimum temperature of the soup approaches 70 over time. That is correct. What's happening here is this is your asymptote. Usually we have it written over here. The asymptote is 70. We have soup that's coming down, and it's approaching this asymptote at 70. Let's see, this is the x-intercept. It's approaching the asymptote, which ends up being 70. We can look at our table and just kind of see as we scroll over time. Oops. Did I mess up my graphing? Yep, I messed it all up. That was supposed to be 70. All right. Should be approaching 70 over time. So yeah, you see that 70, 70, 70. Yep. All right, let's scroll back to normal. Okay. And then I'm going to change back to counting by ones because that's just nicer. All right, I am going to stop there for now.